All right, so for the first one, this is your thank you for attending question. You know how I always like throw you at least one of those. It is just checking that you know what a conjugate is. So if a polynomial has a 0, -4 plus 7i, then another 0 it must have would be -4 minus 7i. Literally, that is it. That is all I'm asking you for. I'm just checking that you know what a conjugate is. Do you remember that homework assignment where like the first 3 problems I made were those? It's just like the opposite. Yeah, that was good. All right, 2 and 3 are very similar, so I'm just going to do number 2. All of the answers are on Schoology, okay? So, 2 and 3 are similar. I'm just going to do question 2. So we're going to write an equation, f of x equals, we want zeros, x equals 3. All right, what would be the factor if we have x equals 3? Perfect, x minus 3, because 3 minus 3 equals 0. And then for the square root of 2, you're going to have x minus square root of 2. And then you'll also have x plus square root of 2. That's like question number 1. It's the conjugate pair. The irrational ones, which are those weird square roots, and the imaginary ones happen in those pairs. And then we're just going to multiply it all together. This is like the tedious but not difficult part. Do these 2 first, because some stuff is going to cancel. So just leave that x minus 3 alone. And then multiply these. X times x will give you x squared. Outsides and insides cancel because one's positive and one's negative, so that's kind of nice. And then just multiplying the last. A negative times a positive is going to be negative. What is square root of 2 times square root of 2? Just 2. Perfect. The roots cancel. And then we're going to multiply all of that together. So it will be x to the 3rd. And then the insides will give you minus 3x squared. And then the outsides will be minus 2x. And then the lasts will be plus 6. Negatives cancel there. So again, I'm going to skip number 3. The reason I like to skip a few is it gives you something to try and then check your answers for next time, because you don't have like an official homework assignment for a test. So maybe like go back and do the ones that we skipped for practice. The answers are on Schoology. All right, 4 and 5 are also similar, so I'm just going to do number 5 because they're the same kind of thing. All right, so write the equation of a polynomial with a 0 of x equals 2. So that would be a factor of x minus 2, and it's to the 5th power, multiplicity of 5. So you could draw out that whole triangle. I think some of you have probably like accidentally memorized the coefficients by this point. Do you know what I'm saying? Like, does anyone remember what it is for 5? If not, you can always draw it out. Yeah, 1, 5, 10, 10, 5, 1. Again, you can draw out the triangle. That's fine. Those are going to be your coefficients. And we're going to start with x to the 5th. And it'll be a countdown. So x to the 5th, x to the 4th, x to the 3rd, so on and so forth. That 5's not real good. Let me fix it. And then I'm going to treat this like a positive 2. It's going to go the other direction. So we'll have 2 to the nothing, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, so on and so forth. But then because it is negative, what are we going to do? Yeah, flip them. So the first one's positive, second one's negative, positive, negative, positive, negative. So anything to the 0 power you can ignore. That would just be 1. So you can scribble those out. Anything to the 0 power. I still write it in because it's part of the pattern. I feel like it helps to keep it in there for the pattern, but you can ignore that. And so this will be x to the 5th minus, all right, this is where you have to actually like do the math. This is where you have to multiply some numbers together. What's going to be this one? Good. 2 to the 1st is 2 times 5 is 10, x to the 4th plus, what will this one be? $40. Good. Why 40? How do you get that? That's correct. Yep. Good. 2 squared is 4 times 10 is 40. All right, I'll talk you through this one. 2 cubed. 8. Good. Times 10. We 80. 2 to the 4th. That's 2 times 2 times 2 times 2. Count on your fingers if you need to. 2 to the 4th. 16 times 5 is also 80. If you didn't know that off the top of your head, work it out off to the side. You will get 80. All right, and then 2 to the 5th, 32. Yeah, minus for that. Technically, I have not been marking this wrong. Technically, there should be an f of x equals out front because I asked you for the equation. I didn't take off for that because for heaven's sake, but technically that should be it. All right, 6, 7, 8, 9, or yeah, 6, 7, 8, 9, 10, 11. These are all of the graphing characteristics. I am not having you do a full list of all the characteristics in a graph for all 6 of them, okay? There's only 2. All the others, I just like picked and chose a couple of characteristics, and I am literally going to tell you exactly what they are right here and now. If you listen, I'm going to tell you exactly the way it's going to be on your test. You understand? Understand that this is your test and I just changed some numbers. I'm going to tell you exactly what it is on your test, okay? So for number 6, the only characteristics you would have to do are the vertical asymptote, the horizontal or slant asymptote, the whole, and the end behaviors. That's it. I'm not having you do a graph. I'm not having you do the whole list. I'm going to tell you exactly which stuff I'm going to ask. All right, so for number 6, we do need to factor this. So how is the denominator going to split? It'll be x and then what? Three and 5? 3 times 5 will give you 15. All right, perfect. And then what symbols will we need to get -8 in the middle? Yep, good. They'll both be negative. So what cancels out? Good. So let's do the whole first, because that's going to be the whole. The whole will be 3 something. How do I get the something? Plug 3 back in. Now it's a little tricky because the entire numerator is gone. What's really in the numerator if I crossed out the whole thing? 1. Good. So I would put like a 1 there. This is what we're plugging back into. This 1 over x minus 5. That's what's left. All right. So if you plug 3 into that, 3 minus 5 would be -2. So good. But it's in the denominator. So -1/2. All right. Vertical asymptote. This factor gave us the whole. So this one's going to give us the vertical asymptote. So it'll be x equals what? 5. Good. Perfect. 3 and 5 were your 2 troublemakers there. So 3 became the whole, 5 became the vertical asymptote. All right, horizontal or slant asymptote, you have to compare the powers. Let me write it out off to the side. I know you have it in your notes from before, but let me just, because we're reviewing, so let me go over it again. If your numerator power is smaller, it is automatically going to be 0. If they are equal, do you remember what we do? If your coefficients, and if the numerator is bigger, then it is a slant asymptote, and that's when you have to do a synthetic. We're going to do a comparison. So for number 6, which one of these 3 situations is it? We'll call them the first one, the second one, or the third one. Which one of these 3 things is happening? Good, the first one. In the numerator, we just have an x. The denominator is x squared. So it's automatically going to be y equals 0. And so if the horizontal asymptote is 0, what are both of the ends going to be? 0. They're going to have to match. The horizontal asymptote is where it levels off on either side. So if that's 0, both of the ends are also going to have to be 0. All right, we'll do a couple more and then I'll give you a break. All right, for number 7, all I'm going to ask you are the X-intercepts, the Y-intercepts, and the vertical asymptote. Again, like I'm not going to ask you every single thing on every single question. That would be way too much. I'm just kind of like picking and choosing a few things. But still, the first thing that you want to do is factor. So what can we factor out of the numerator? Good, 4. And then you would be left with, good, x minus 2, perfect. I am really proud of you guys with picking up with the factoring. I know last year was really weird with Algebra 2 and we didn't have time to like do a unit devoted just to factoring and you guys kind of had to like remember it as we went. You've done an awesome job. All right, denominator, it's going to split x and x, and then how will 8 split? 4 and 2. And then symbols, they'll both be negative. So this cancels. That means that would be what? The whole. But I didn't ask you for that, so forget it. You just don't need it. Just forget about that. We're only going to look at this part. Okay. X-intercept, you want to set that equal to 0. Hey guys, does 4 equals 0 make any sense? No, so there just isn't one. Y-intercept, how do we get that? Good, plug in 0. So we're going to plug in 0. So 0 minus 4 would be negative 4. 4 over negative 4 would be negative 1. Good, and then vertical asymptote will be x equals, what makes this 0? Who's our troublemaker? 4, x equals 4. All right, we'll do one more and then we'll do a break. I know a study guide is not like super exciting, but I know everybody like wants to do well on their test, so I'm gonna make sure you know what's on it. All right, for number 8, I'm only going to ask you the domain, vertical asymptote, horizontal or slant asymptote, and the ends. All right, so again, the first thing you want to do is factor. So what can we factor out of the numerator? 3x, and that'll leave you with x plus, this is kind of tricky. There will be a number there. What's going to go there? It'll be x plus what? 1. Good. Anything divided by itself is 1. And then the denominator is a difference of squares. It'll be x plus 2, x minus 2. So domain, oh, nothing canceled, which means there's no whole, but I didn't ask you that anyway, so don't worry about it. Domain, who are our troublemakers that are going to get kicked out? Who is not invited to the domain party? Yep, 2 and negative 2. Now you have to go left to right, so skip over the negative 2 first and then the positive 2. But those are your troublemakers. Now, the 2 and negative 2, they can either become a whole or a vertical asymptote. Nothing cancels, so there is no whole. So what does that mean? Yet they're both going to be vertical asymptotes. So you have 2 of them. Because nothing canceled out, so there is no whole. All right, and then for the horizontal or slant asymptote, again, it's going to be one of these 3 situations. Compare the powers. Which one of these 3 things is going on? They're the same, so we're going to use the coefficients. And your coefficients are 3 over 1, which would just be 3. So what that means is your ends level off at 3. So what are your end behaviors? They're both going to be 3. Yeah, like it's going to match. So it's going to be the same thing. So if you got this answer wrong, like say instead of 3, you wrote y equals 7 for some random reason, I would mark that wrong. But if you made both of these match, I would mark these correct. Does that make sense? Like I'm not going to take off twice for 1 error. All right, do a little brain break and then we'll keep going with you. All right, for number 9, you're going to do the whole everything. So we're going to do the whole list and a graph. This is like on your quiz. So domain, range, x-intercept, y-intercept, whole, you know what, let me look at my list, make sure I don't miss something. Like I generally have it memorized, but I actually know I set that aside. Vertical asymptote, horizontal or slant asymptote, increasing, decreasing, and then the ends. I think that's everything. I got it all. Obviously on the test, it will be printed on the paper and you won't have to write that. Okay, but give me a break. You can abbreviate it. You understand that in college, your notes are like never going to be handed to you just to fill in. Like they're just going to write on the board and you're going to have to copy stuff down. That's how that's going to be. All right, we're going to need to factor this. So go ahead and split the numerator. So that'll be x and x. And how would we split up 6? Yep, 3 and 2. And to get a -1 in the middle, yeah, -3, +2. Okay, it looks like something almost cancels, but it doesn't. All right, so what does that mean? I can put none on. Well, there is none. Who's your troublemaker? 2, kick out 2. 2 is causing problems. So if 2 isn't the whole, what is 2? Vertical asymptote is x equals 2. And I like to graph it as I go along. So I'm going to go ahead and put that in at 2. Oh, yeah. And you just said the next one. The numerator degree is bigger than the denominator. That means we're going to have a slant asymptote. And so you're going to need to do a synthetic division. So 2 goes in the little box. Your countdown is in order. It's 1, -1, -6. Will the remainder be 0? I don't know. Put the phone away. Not necessarily. It comes out to whatever it comes out to, but do we use the remainder anyway? Put the phone away. All right, so bring down the 1, multiply, add until you get to the end. So I got 1, 1, -4. We're not going to use the remainder. And so your slant asymptote is y equals, and they both came out to 1. How do we write that equation? Yeah, it's 1x plus 1, or just x plus 1. So welcome back to Algebra 1 class. Do you remember good old y equals mx plus b? All right. You're going to start at 1 and do a slope of 1. Now, obviously, on the test, you will have a grid. It will be a little bit easier. I don't have a grid here, so I'm like doing my best. It's like good enough. So now we need some points to plot. Let's go back and get the intercepts. There will actually be 2 x-intercepts because we have 2 factors here to set equal to 0. What's going to be our x-intercepts? What will this first one give us? Good, 3, 0, and then what's the other one? Good, -2, 0. So 3, 0, and -2, 0, and you can plot those on your graph. So right there and right there. And then y-intercept, we're going to plug in 0. You can plug it into the factored version or the original version. It does not make a difference. I think because nothing canceled, in this case, it might be easier to use the original one. If you plug in 0 for all these x's, what are you left with? Yeah, good. It would be -6 over -2, which would be 3. So 0 is 3. And then you can go ahead and draw in your graph. Just go through those points and don't run into the asymptote. It's going to look something like this. There's a cute little graph. And then once you have the graph, you can go ahead and pick up all the stuff that we skipped. Range, you're going to sweep downwards to upwards. What is your range? Yeah, all of everything, right? There weren't any holes. And there wasn't a horizontal asymptote, so it's not leveling off anywhere. You get everything. This you have to read left to right. As you read left to right, what is the graph doing? Increasing. That means you copy over the what? The domain, because you're reading left to right. So for increasing, copy over the domain. Decreasing will be none. And then go ahead and set up your end behavior, and I'll cover up the middle of the graph. It's easiest if you just cover that up. So -infinity means look to the left, +infinity means look to the right. If you cover up the middle, where is the left end going? Yeah. Negative infinity, right end, positive infinity. All right, number 10 is the other one where I have you do the whole everything. Okay, there were only 2 of them where I'm going to have you like do the entire list. So number 10, we're going to do all of it. Do you need to go get some water? Do you want to get some water? Okay. Thanks for being good sports and write out the list. Again, on your test, obviously it will be printed for you. I think it's good for you to have to do that every once in a while. Again, when you get to college, nothing's going to be handed to you. You're going to have to write down everything. So it's good practice for the future. All right, for the numerator, that's going to be a 2-step factoring problem. First, what can we take out of all of these? 3. So if you take out 3, you'll be left with x squared plus 3x minus 4. And I'm going to come down here and write on the paper. Then that's going to split. So it's a 2-step problem. First, you have to take out the 3. Then you have to split it up. Ms. Cole, is there a way to do that in 1 step? No, you kind of have to do that. So this will split x and x, and then how will we split up the 4? You can do 1 and 4 or 2 and 2. Yep, 1 and 4, and then we want a positive 3x in the middle, so plus 4 minus 1. All right, and then the denominator is going to split into what? Good, 3 and 1. And we want a negative 4 in the middle. So they're both negative. I'm wishing I hadn't written that there because now I didn't leave room for to write my domain in there, but that's okay. I'll just write it off to the side. All right, who are our troublemakers? Who are we kicking out of the domain party? Yeah, 3 and 1. So domain, I'm sorry, I made a poor decision there as far as where I wrote it. We're going to kick out 1 and kick out 3. So they can become either a whole or a vertical asymptote. There will be a hole in this graph. Which one of those is going to become the hole, 1 or 3? Good, 1, because this is the factor that cancels out. So the hole will be 1 something. You're going to take 1, plug it back in. All right, let's see what we get. You have to plug 1 back in for what's left here. 1 plus 4, 5, times 3, 15. All right, so the numerator is 15. And then in the denominator, 1, we're plugging in 1, right? 1 minus 3 is negative 2. Okay. It's negative. 15 halves. Well, 16 halves would be 8. 14 halves would be 7. Do you see what I'm saying? Like it would be halfway in between 7 and 8. It would be negative 7.5. So 1 negative 7.5. So like right about there. So 1 became the whole. That means 3 is the vertical asymptote. So x equals 3, and you can bet that. All right, horizontal or slant asymptote. Go back and compare the powers. I know this is real small, but you have it printed on the paper right in front of you. Which one of these three situations is going on? They're equal, so you're going to use the coefficients. It would be 3 over 1, so 3. So y equals 3, and then you can dot that up. So hey, what other answer is also going to be 3? Yeah, the end behavior is also going to be 3. If you just even want to go ahead and like fill that in right away, like whatever that horizontal asymptote is, that's what the ends are going to be. Like that answer is going, it's the same answer. So just go ahead and write it for that too. There's no rule about what order you need to do this in. So if answers match, just go ahead. A lot of these are 3 as well. Threes in the problem. All right, let's go and get the X-intercept. It's going to be something 0. What makes this 0? -4, are you with me there? Following where I'm pointing there? All right, -4, 0. And then your y-intercept, you're going to plug in 0. You can plug it in the factored version or the original. Sometimes I think it's easier to use the original one. I'll just cover up all the x's. If there's 0, they're gone. You're left with -12 over 3, which would be -4. So 0, -4. And then you can go ahead and fill in your graph. Just connect all the dots and make sure you connect to the whole as well. And just don't run into the asymptote. All right, and then you can go and pick up all the stuff that you didn't answer yet. Range, you're going to sweep downwards to upwards. Who is not invited to the range party? Yeah, the whole, so negative, what was it? -7.5, -15 halves. And then who else is getting left out? 3. And then lastly, reading left to right, is the graph increasing or decreasing? It is decreasing. So what do you copy over for decreasing? Domain, because you're reading left to right, and that's the domain. Increasing, we'll say none. All right, so again, there's only 2 that I have you do the whole process for. Again, all the others, I'm just kind of picking and choosing. So for number 11, and I'm telling you literally exactly which stuff you have to know. For number 11, it's only going to be the domain and the intercepts and the whole. Usually what I get is people are like, I'd rather do the whole list. Is anybody like that? I don't know. Usually I hear that, like, I don't want to just do a couple of things. I want to do the whole thing. I like hearing that because it's like you're putting it all together, but at the same time, I'm not trying to make you do that for every single problem. All right, so number 11, the numerator is going to split x and x. And then how would 14 split? Yep, 7 and 2. It'll be -7 plus 2. So for the domain, who's your troublemaker? Who's getting kicked out? -2. That cancels, so -2 will be the whole. It'll be -2 something. Take -2 and plug it back in. There's not a whole lot left. If you plug -2 back in, what do you get? This is all that's left here. -2 minus 7, good. -9. X-intercepts will be something 0. What's going to make this? This is the only thing that's left. What's 7, 0, good. And y-intercept, you're going to plug in 0, 0 minus 7, -7. All right, so again, we don't need to do every single one. I'm going to pick a few. Well, actually, I'll do almost all these. I want to leave one for you guys to do for practice at least. I'm going to leave number 14 for you, but we'll do the rest. All right, so for number 12, First, you need to factor the denominator that's right there. So it'll split x and x, and then 3 and 4. And to get a negative 1x in the middle, you'll need negative 4, positive 3. Oh my gosh, those are the same things that are right there. It's like she made the problem so that it was going to work out. Now you're going to need to multiply that common denominator to all three of these, x plus 3, x minus 4, to all three of them. Ms. Cole, I don't want to. That's fine. I'll just mark it wrong when you mess it up. Because if you can't see what's still there, then you're going to have trouble, okay? Or you'll drop a negative sign or something will happen. Like my pep talk is just write it. It only takes a few seconds. It's like not a big deal. And then you'll be fine moving forward in the problem. All right, so what cancels in the first fraction? Yeah, x plus 3. And then you can see what's still there. I know mine kind of went into the directions there, but you have x times x minus 4. Now you have to distribute that x. So if you distribute, what are you gonna get? Yeah. I can, everyone like livened up. You guys like this better than the graphing, you can tell. It's like very algebraic, right? For the second one, what cancels? X minus 4. Now what's left is negative 2 times x plus 3. So when you distribute, you have to distribute a negative 2. It'll be negative 2x minus 6 equals. All right, and then what cancels for the last one? Both of them, and you just have negative 14. All the fractions went away. That was the whole idea. Now we're going to get the like terms together and evacuate. Bring everything over to one side so it all equals 0. So this will be x squared minus 6x. And then we have to add this 14 over. So negative 6 plus 14 will give us 8. The reason we set it equal to 0 is now we can factor it. So we're going to split that apart. It'll be x and x. 8 will split 4 and 2. And then what symbols do we need to get negative 6? Both negative. Perfect. So your answers are x equals 4, x equals 2, but you have to check them. Do we get to keep them both? Do we have to get rid of one? Do we have to get rid of both of them? What do you guys think? Why do we get rid of 4? Because that's correct. Yeah, it'll make the problem denominator 0. 4 minus 4 would be 0. This one you get to keep. Who would have been the other troublemaker? Negative 3. Good. All right, let's do number 13. This one you can cross multiply. You have one fraction equals one fraction. So we're just going to cross multiply it. So this direction, you would have negative 6x equals, now the other direction, you would have x plus 4 times x plus 3. I'm writing it out. If you're comfortable multiplying that in your head and just want to go ahead and skip that step, that's fine with me. I'm just writing it out so everybody can see it. So this is FOIL. You'll have x squared and then plus, what did the outsides and insides give you? 7x, good, plus 3 times 4, 12. Again, you're going to evacuate, get everybody to one side so it all equals 0. So that'll be x squared plus 13x plus 12. And then we're going to factor that. So this time, how will the 12 split? Yeah, weirdly, we actually use the 12 and the 1 for once. They'll both be plus. And so you get negative 12 and negative 1. And then check them. Do we get to keep them both? Get rid of one or the other? What do you guys think? You get to keep them both. What number would you have had to get rid of? Negative 4. Good. All right, cool. I'm going to leave 14 for you guys. You don't have a homework assignment. How many did I skip on the front? I think I only skipped like 2. Okay, I didn't skip that many. We're doing almost the whole thing, right? So number 15. Okay, here's your pep talk on this. It is a word problem. All that means is you have to set up the problem yourself. If you lose your mind, invent a problem and solve it. I will be able to give you like a point for solving the made up problem. Do you get what I'm saying? Okay. I'm not joking. I'll give you, if you make something up and solve it, I'll give you a point. Now it says sum. What does sum mean? Adding. So you're going to have something plus something equals something else. If you even just want to set it up like, you don't have to do that. I'm just saying like that's what it's going to be. Something plus something equals something else. All right, how would we write 3 times a number? 3x, that's what goes on the first line. Twice, that means 2 times the reciprocal of the number. How do I do the reciprocal of x? 1 over x, good. Is, that means equals 5. That wasn't too bad. Look, you all survived. All right, we're going to go through and multiply by the denominator, which is x. So all of these are going to get multiplied by x. To cancel that out, that's the whole point. You want the fraction to go away. So that would make this first term 3x squared plus 2 equals 5x. And now it's just like the other ones. It's evacuate, get everybody to one side so it all equals 0. And then you're going to factor it, set the factors equal to 0. So that's going to split 3x and 1x. 2 is going to split 1 and 2. Let's see. I think we would need the 2 here and the 1 here. Let's see some. The outsides give you 3x. The insides give you 2x. That will give you 5. We need them both to be negative. If you put it the other way, it'll still work out, but the symbols won't be right. You need for this to be a positive 2. So a negative times a negative will give you a positive. If you do it the other way around, you'll get a plus and a minus, which would make a negative 2. So the pluses and minuses won't work out if you do it that way. That happens a lot with 2 and 3. All right, so what does that first one give us? 2/3, perfect. And then this one is 1. You get to keep them both. What's the only number you would have had to get rid of? 0. Good. All right, and then these are your inequalities. These are all the number lines. This is what we did last time. All right, so number 16, we're going to need to factor this. Numerator is going to split x and x, 2 and 1. Oh, whoops, I'm sorry. Let's get that down. We'll need a -2, +1. And then the denominator will be x and x, 3 and 1. And then they're both going to be negative. So we are going to make a number line for each one of those. Again, it's going to look like a musical staff, sort of. Just try to stay organized. I know drawing a straight line can be hard sometimes. Just do your best. Like it's more about being organized than anything else, because none of those factors is real hard. Now you do have to get the zeros in order because they're number lines. So it has to go smallest to biggest. So what's going to be the smallest 0 out of all of those? Like if you set those equal to 0, which one's going to give you the smallest result? Yeah, this one will give you -1 because we have to put them in order. All right, and then what's the next one? Yeah, good. This one will be +1. And then this one will give us 2. And then this one will give us 3. So you do have to put them in order left to right. Did anything weird happen? No. So do you remember how to fill them in to save you some time? It'll be negative to positive. They will all be negative and then turn positive. If you don't like that, you can always pick a test number, but I am just trying to save you some time. And then you slice up your number line into all those sections. Spoiler alert, it's going to alternate. We're going to find what the overall sign is for the whole thing. So when you look at the first section, it's a negative times a negative times a negative times a negative. That would be positive. You have an even number of negatives. And like I said, it's going to alternate, but look at the next one. You have 3 negatives. So that'll be negative and positive, negative, positive. What's that? Yeah, as long as you like check the first one, you can pretty much make it alternate. Now, which ones are your answer? It comes back to this symbol. What does that symbol mean? Greater than, that means we want the positive parts. I found that this helped people if I colored them in. So I started doing that. I was like, okay, if I color them in, if that helps you. So anyway, those are the sections that we want, the positive ones. And then bracket or parentheses. Good, because there's not an equal to, so they're all going to be parentheses. So this first section would be negative infinity to -1, union, and then what would the next one be? From where to where? Yeah, 1 to 2, union, 3 to infinity. And you know what I think I'll do? I'll start you on 17 and let you guys finish it. I'll get you to the point of the number lines and then I'll let you guys finish it because I have all the answers on Schoology. You can check it. So the first thing that you have to do is get 0 on one side. So we're going to have to move this over so that we have 0 on one side. So I literally just subtracted the entire fraction over. Algebra is just moving things. Like I just moved that to the other side. And then we have to mush the 2 fractions together. I know that sounds very technical, but you have to take the 2 fractions and make them 1 fraction. This is your common denominator. You just need both of them. So you're going to multiply them by each other. I was bringing up, do you remember the Jack and Jill problem? They were looking for the needle in the haystack. We had a 1/3 and a 1/5, and the common denominator was 15. You just times them together. We're doing the same thing here. It's just there's variables. So this one gets multiplied by the x minus 1. This one gets multiplied by the x plus 3, and we're going to put it all together. So for this, you will need to distribute the 2. That'll be 2x minus 2. For this one, you are not distributing 4, but -4. Good. So -4x minus 12. And then it is over the common denominator. And then you can make your number lines. The ones in the denominator are obvious. That'll just be x minus 1 and x plus 3. And for the numerator, you would want to put the like terms together. So what would that give you if you put the terms together? -2x. Hey, that's weird. There's a negative with that one. Do you get what I'm saying? Like if something strange happens, you're going to be like, hey, that was weird. All right, and then -14. Actually, you know what? I may as well, like, I was thinking I would let you finish it. I'll just go ahead and finish it. It's not going to take but a minute, right? What's going to make each of these 0? Let's see. This one would be -7. And then this one would be -3. And then this one would be +1. So the first 2 are straightforward. They're going to be negative and then turn positive. And again, you can always pick a test number, but I'm trying to save you some work. Do you remember what happens if you have the negative out front? Instead of negative to positive, it's positive to negative. Yeah, like it's just backwards. All right, and it's going to alternate. What's the overall sign for the first section? Good, positive. Negatives cancel. So positive, and then this one will be negative, positive, negative, like a battery. Which sections do we want? Well, what is this symbol telling us? Less than. That means we want the negative sections, brackets or parentheses. Okay. So the problem says brackets, but you can't bracket 1 and you can't bracket -3. Why not? because they're your troublemakers. They'll make the denominator 0. You can bracket -7, but these two are going to have to be parentheses. All right, so when you write your answer, it'll be bracket on the -7 to -3 with a parenthesis, and then parentheses 1 to infinity. So I know the problem has an equal to, so it means brackets, but the only number you can bracket is the -7 because the others are your troublemaker values.